In this video, we're going to review solving quadratic inequalities. We're going to approach solving quadratic inequalities much the same way we approached solving quadratic equations. Here's our first example, and we have x squared minus 9 is less than 0. Just like with solving an equation here, we want to factor our quadratic. So we're going to take x squared minus 9. This is actually a difference of squares, so it factors as x plus 3 times x minus 3, less than 0. Then we're going to kind of just ignore that inequality sign for a little bit. We're going to set each factor equal to 0, just like when we solved quadratic equations. And that gives me x is equal to negative 3 and x is equal to positive 3. Then we're going to test some values. So we need to start with a number line. And we're going to put these two numbers on the number line. So let's put 3 here, and then we'll put negative 3 down here. And then on those two values, we're going to draw these dotted lines, which are going to serve kind of as dividers. Now, on this number line, we want to add some more numbers. Right here, we could put negative 4. That's definitely not the only number to the left of negative 3, but it's the immediate number, so that'll work. In between negative 3 and 3, I'll just use 0, but I could use any number in there. And after the 3, I'm going to put 4. And I'm going to label this section A, this section B, and this section C. And I'm going to test values in the original inequality. So in section A, I'm going to let x equal negative 4. Because in section A, negative 4 is over there. We're not going to use the negative 3 or the positive 3. So when we plug that into our original problem, this gives me negative 4 squared minus 9 is less than 0, which is 16 minus 9, which is less than 0, which is 7, which is not less than 0. This gave us a false statement. So because that's false, that means none of our solutions lie in section A. So now we're going to do the same thing for section B, and you want to pick any number that lies in section B. So for example, I'm going to let x equal 0. If I can pick 0, I'm going to pick 0 because it's usually very easy to work with. Plugging into the original inequality, 0 squared minus 9 is less than 0. 0 squared is 0, so that's gone. Negative 9 is less than 0. That's a true statement. So that means we do have solutions in section B, so we want to shade that section. Okay, shade that in. And then we're going to just check section C. And we'll use 4, because 4 is in section C. So we're going to test x equal 4. That gives me 4 squared minus 9 is less than 0, which is 16 minus 9, which is less than 0. And 16 minus 9 is 7. 7 is not less than 0. That's a false statement. So again, that means we don't have any solutions that are in that section. So our solutions to this inequality are only right here in section B. 0, 1, 2, negative 1, negative 2. Then we go to the original problem, and because that is just a plain less than, that means we need to use some open circles, just like we did before when we talked about linear inequalities. So an open circle on the negative 3 and an open circle on the 3. So our solutions lie between negative 3 and 3. And this is actually an and type problem, which is much like what we saw in the previous video on inequalities. So you can actually use that same acronym, less than, and, greater than, or, to help you remember what the graph should look like. So in our next example, we don't have to do quite as much work because that's a greater than sign. And we remember that if it's a less than sign, it's an and problem. If it's a greater than sign, it's an or problem. So this is an or problem. So our graph should have arrows going in opposite directions and probably a little gap right there in the middle. So if you can remember that, then you don't have to spend as much time checking the different sections of the number line. You do want to factor this, and so x squared plus 3x minus 4, that factors as x plus 4 times x minus 1. 4 times negative 1 is negative 4, and 4 plus negative 1 is 3, our middle term. Set those equal to 0, just like solving quadratic equations. Solve for x. We get x is equal to negative 4, and we get x is equal to 1. And we already know it's an OR, so we're going to put some numbers on our number line. And we'll put negative 4 down here, 1 here. That's a negative, that's a positive, so I'm just going to use 0 in there. Even though 0 is not exactly in the middle, that's okay. And looking at my original inequality, it's just a plain old greater than. It's not greater than or equal to. So I know I'm going to use open circles. And my solutions are going to be less than negative 4 and greater than 1. None of my solutions are right there in the middle. So solve by factoring just like you would an equation, but then remember that if it's a less than or equal to, it's an and graph, so you're shading in between the numbers. If it's a greater than or equal to, it's an or graph, so your arrows go in opposite directions.